Hello friends, welcome to Shiksharthi. In this video, we shall be discussing how to represent 4 elements in a Venn diagram or on a Venn diagram. So let's start. Now if you have seen my earlier videos, we have already talked about 4 things or 4 events. We have already talked about 2 things or 3 things being represented on a Venn diagram. But in this session, we'll be talking about how to represent 4 different things or talking about 4 different sets to be represented in terms of a Venn diagram. Now, when we talk about 4 things, the very first thing which comes into picture is how do I have a diagrammatic representation of the same. For example, when we were talking about 2 things and the representation of 2 things, we were using circular format. We were using 2 circles and we were representing it in terms of the circular way of Venn diagrams. For 3 things also, we talked about the circular representation only. Now, when we talk about 4 things, will we talk about the circular representation only? But in that case, before we choose how to represent it, whether it is a circular format or a non-circular format, let us talk about how many things will we talk about when we are talking about 4 different cities, for example. So if I say I have to represent 4 different cities, let us say A, B, C and D on a Venn diagram. So the first question that comes to me is, or the first thought that comes to me here is, okay, is it a circular format that I'm supposed to use or a non-circular format? So while this ambiguity is on, if I start reasoning out how many cases can I make, probably that helps out or that eases the situation. How? So I'll use the word either choose or I'll use the word select. So if I select or choose any one of them, so let's say I'm select any one of them. This is the first case that I would talk about. The second case that I would talk about here is select any 2 of them. The third case here that I can talk about is select any 3 of them. Fourth case I can talk about it is select all of them. So when I say select all of them, I am basically referring to selection of all of these, each of these. And the last thing is I have a choice. So the choice should always be democratic in nature. So when I say that the choice is democratic in nature, that means I have a choice not to choose. So these are the cities that we are talking about. These are the 4 cities. So there is a choice that I may not choose any of these. So none of them, let's say. So how do I start this? The best way to start is with the help of logic. You can always make cases and then you can work out a formula for the same. So now when we are trying to work out cases, so I can say when selecting any one of them means what? Either you selected A, B, C or you selected a D. How many cases have we made? We have made 4 cases. So here we are talking about cases and which of these have you selected? So which of them have you selected or not selected? And then you're talking about the total number of cases. Okay, now when you say choose any 2 of them, this can be done in a very linear manner. So let us say that you start from this side and then you start choosing and move on to the right hand side. So you start off with A, B. Then you choose AC, keeping A as constant, choose AD. Next you can keep one of them as B. And the last case here is D. So how many cases have we made in total? 6 cases. Now when you're choosing any 3 of them, any 3 means, let's say ABC, ABD, ACD. The next one here is BCD. There is no other such case in which you can choose any 3 of them. And the last case that you're supposed to make here is choosing all of them at the same time. So now something that has been kept constant here is at a particular time you're choosing any one of them, at a particular time you're choosing any two of them, at a particular time you're choosing any three of them, at a particular time you're choosing all of them, or at that time you're choosing none of them. So here you again have 4 cases. You have one case here and you have one case here. So what are the total number of cases that we have made here? So 10, 14, 15, 16. Now these 16 cases will help you to decide the way in which you'll be presenting all these cases in terms of a Venn diagram. Now this will help you. So if I have a circular format, maybe you can try it out. If you have a circular format, the circular format at the max can, let's say if I'm taking all 4 circles of the same size. So this gives me a hint, maybe in order to generate. So let's say how many cases have we made here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you circumscribe it inside a box. So you have made 12 cases. Maybe if I revisit it, I would say that there is one more case which could have been made here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and one more 13. So if I take 4 circles of the same radius such that I make sure that their intersection gives me maximum number of mutually exclusive parts, at the max I will have 13 such cases. But we want how many cases? We want 16 cases. So how do we make these cases now is we can't use a circular format. Now once we know that we can't make a circular format, that means neither can you use a circle nor you can use ellipse or any other form of a circular format. So what is the next format that you can use here is maybe a non-circular. So non-circular is what? Either I use only linear format, linear is straight lines, or I use a combination of linear and circular both. Right? So now when I see all these cases, now if I talk about the first case or the second case, third, fourth, fifth, all these cases are mutually exclusive to each other. I mean, when I say mutually exclusive, what I mean to say is they don't have anything in common except for their boundaries will touch each other. I mean, they cannot coexist. So when you are selecting any one of them, there is no question of selecting any two of them. I mean, they will not be able to coexist except for the fact that their boundaries will touch each other. It is just like saying that there are 16 neighboring countries which do not have any relationships between them or between one another, right? Among one another. And the only point of contact is something that is common between those 16 cities, or let's say is here is they are neighbors to each other, their boundaries are touching each other. So now how do I make these 16 cases? Once I know that I'm supposed to make a square or a combination of a square or let's say a rectangle along with a circle, the first thought that comes to my mind is a 3 into 3 matrix. So when I say a 3 into 3 matrix, what am I basically talking about? I am talking about a 3 into 3 rectangle or a square. Now how many sections do you have? You have 9 sections. And now if I circumscribe it, so let us say I put it inside a box. You already have 10 cases now. You are left with how many cases? 16 cases. So from here you get a fair enough idea. Either I make again a linear figure, or if I make a figure like this, let's say. So 1, 2, 3, and similarly I can have 3 cases here. So this is the logic behind the diagrammatic representation of 4 things. When you're talking about 4 things, or you're talking about 4 different sets, maybe they have various number of elements. For example, I can say set A is a multiple of 2, set B is a multiple of 3, set C is a multiple of 5, set D is a multiple of 7. And what is mu? Mu is the universe of discussion. So in this case, when I'm saying that these are cities, the universe of discussion becomes what? Cities. So that means I'm talking about 4 cities and other than those 4 cities. Now what is other than those 4 cities? The area which remains outside these these 15 areas that we have talked about, is when we talk about none of these cities, none of them. So let's say here mu is, we are talking about cities, and under the head of cities, let's say this is city A, this is city B, this is city C, and this is city D. And outside this is, we are talking about none of them or none of these. That means we are talking about all other cities, maybe in the same country or outside that country or whatsoever. That is not the point of concern. The point of concern here is we are talking about cities. Okay. So mu represents the entire universe of discussion with respect to the domain, the noun that we are discussing. So here we are talking about cities. We could have talked about the marks of 4 individuals inside the class, or we could have talked about 4 subjects, and other than those 4 subjects whatsoever. We could have talked about 4 colleges, and other than those 4 colleges in a country or in a city whatsoever. Here we are talking about a city. Okay, so can I say this is the entire area which belongs to A? This is the entire area which belongs to B. This is the entire area which belongs to C, and this is the entire area which belongs to D. So if you have seen the earlier videos, we have talked about the difference between 2 terminologies that we use. One is we talk about city A, or we talk about city A only. There is a difference between the 2. So that means when we are talking about city A, along with city A, I can talk about any other city. Now when I am talking about any other city, I can talk about 1 more city, or I can talk about 2 more cities, or I can talk about 3 more cities along with A. But when I am talking about only A, that means along with A, there is no scope for any other remaining city. Right? So can I say this portion specifically is A only? So let us first talk about selection of any one of them at a time. So this is A only, this entire portion. Similarly, this entire portion is talking about B only. Analogously, this becomes C only. Analogously, this becomes D only. Right? Now, let us talk about selecting any 2 of them. And we know selecting any 2 of them represents 6 cases. So from where can I get 6 cases? 1, 2, can I say 3, 4, 5, 6? Let's check it out. Can I say this is an area which is no, only talking about this area. This is common only to AB. So we'll say AB only. Analogously, we'll say CD only. Analogously, can I say this area belongs to A and C only? This area belongs to A and D only. A and D only. Now when I am saying AD, if you have seen my earlier videos, if I say AD, this has to be understood as A intersection D. Especially when we talk about Venn diagrams or when we talk about set theory. Okay. Similarly, can I say this is a place which is common only to B and C? This is B and D only. Now talking about choosing any 3 of them, any 3 of them. So here, now this gives me fair enough of hint, or this gives me some benefit here, that if I talk about this, these are the sections that are common to, this represents the choice of exactly 3 of them or any 3 of them. So when I say exactly 3 of them, in that case, I am talking about a particular any of them. So let's say here I am talking about exactly A, B, C only. Here I am talking about A, I am talking about C, and I am talking about D. So A, C, D only. Here I am talking about B, there is no scope for A. So without wasting time, B and C and D only. And here there is no scope for, there is a scope for A, there is a scope for B, there is a scope for D, but there is no scope for C. So can I say A, B, D only? And this is the easiest, wherein we say all of them. Now once this point is clear, now you know how to represent and why are we using, because generally when we learn things, we only learn, we mug them up, that this is the way in which we represent this. But now we have the logic behind why have we used this kind of a diagrammatic representation for 4 things, for a discussion on 4 sets or for a discussion on 4 individual entities. Okay. The next and maybe the last thing which arises here is, okay, now what is the definition of A or B or C or D? So if you recollect my earlier videos, OR represents union. So A union B, union C, union D is represented by a formula. So we can just work out the formula here. Be attentive. So first you are choosing exactly one of them. So let's say now we are not talking about exactly one of them. So let's say one at a time. Mark the words being used. One at a time. Now we are talking about 2 at a time. So we started off with a plus. Now we have a minus again. So this was selection. Let's say representation of one of them, followed by representation of 2 of them. I am not using only. Then, so started off with a plus, followed by a minus, followed by a plus again, selecting 3 of them. Or representing 3 of them. Followed by a minus, which is representing all of them. So in short, now you have the formula. The formula also does not need to be mugged up. And the best way is, you are selecting 1, you are selecting 2, you are selecting 3, you are selecting all 4. So you are using the same logic as you have used here with the sign format. So you start off with plus, then minus, then plus, then minus. This is the formula for A union B, union C, union D, which means what? If I say A or B, I am talking about city A or I am talking about city B or city C or city D. What am I basically talking about? I am talking about at least one of them. Now when I talk about mu finally, so mu will be what? So the things that I have already talked about plus the things that I have not talked about. So it's just like saying A or B or C or D plus the discussion which talks about none of them. So when I am saying none of them, we basically mean what? A complement, B complement, C complement and D complement. So A complement means that you are not talking about A, B complement means you are neither talking about B, C complement means you are not talking about C even, and D complement means what? You are not talking about D even. And when you have written in this format, this goes without saying, you are talking about A bar and B bar and C bar and D bar. Right? So this is what mu represents. I hope this detailed discussion of 4 elements to be represented on a Venn diagram and then thereafter talking about the byproducts of this discussion should not only help you in understanding the topic better, but it should also help you in solving various kind of questions which may follow thereafter. So if you feel that this video is really informative and it makes you escalate to a level which is unimaginable, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do videos on some specific topics, please don't hesitate and put it in the comment section. Thank you so much. Until next we meet, goodbye.